People have always been impressed by Scandinavia for their infrastructure and quality of education. Everyone is aware that such quality is achievable mainly because a good amount of money is poured into it, and it also helps that the Nordic belt has a low population density. We can understand how Norway earns billions with North Sea oil, but for Sweden, most people are clueless. A growing community of analysts believe that Sweden is insanely rich because they have invested a lot into industries throughout the 20th century and took advantage of their neutrality during World War II. However, let's explore for more detailed answers and examples of why Sweden is so sustainably wealthy nowadays. If you look at the bottom of most periodic tables, you find a bunch of elements, usually in a different color to the rest of the table. These are known as lanthanides and actinides. We don't talk about them much, but they power everything in high technology. They make batteries for your phones, microchips for satellites, and magnets for your computer. Most of the technology we use today relies on small amounts of these elements. Although unlike iron or copper, these elements can be quite difficult to get a hold of. On July 12, 2023, the Swedish Deputy Prime Minister made an announcement regarding a significant discovery of rare earth metals in a mine in northern Sweden. According to the Swedish state mining company LKAB, it has discovered the biggest deposit of rare earths in Europe. Rare earth metals include a whole range of elements that are required for the production of smartphones and electric cars. For example, for batteries, catalytic converters, and magnets, but also for lighting. Currently, the largest deposit of these metals can be found in China. It's also close to the largest underground iron ore mine in the world. So, a lot of infrastructure is already in place. Sweden's finding of the deposit is not a big surprise either. Quite a few of the rare earth metals were first discovered in Sweden in 2011, and that's why even many of their names refer to the places in Sweden. What's rare about these metals is finding them in a large enough concentration to be mined profitably. Mining is extremely expensive. It can take 10 or more years for a mine to become profitable. Regulation makes this more expensive, and also because moving tons of rock and dirt requires heavy equipment, people who know how to use it, and people willing to work in harsh weather and working conditions aren't always found locally. So how does biggest in Europe compared to China or the largest deposit so far? A fraction, but very notable nevertheless. This is a deposit of 1 to 2 million tons, and there is estimated to be 99 million tons of rare earth deposits worldwide. While there are roughly 36 million tons of rare earth deposits in China, the CCP have massively over-leveraged their hegemony of this resource, including deliberately bottlenecking exports to increase demand and exert trading influence. Effectively, a major find like this is NATO calling a full house. The mining of this deposit is a huge and expensive challenge, but it will undoubtedly occur given today's socio-political context. The biggest roadblock in ending China's chokehold on rare earth minerals will be to extract the resources with a cost-effective method, whilst also adhering to European standards of working conditions and safety, and also ecological concerns. We expect a lot of industrial automation and technologies on new and larger scales to achieve this within the next 5 years, which could drive prices for such automation down on a global level and thus help other nations break the Chinese monopoly. Those concerns were exacerbated when China retaliated for US measures by restricting exports of 2 chip-making inputs, gallium and germanium, in August, further highlighting the dangers of over-reliance. The tit-for-tat trade measures continued when China announced export restrictions on certain forms of graphite, a critical component in the manufacture of electric vehicle batteries. To mitigate the risk of future disruptions in the critical minerals sector, Japan has worked to establish an alternative rare earth supply chain following China's retribution. The United States injected new impetus into its battery sector last year with generous Inflation Reduction Act tax credits. There is a lot of controversy on this, with gas giants such as Shell having positions on the board of the European Clean Hydrogen Alliance, and there is a potential loophole for the use of gas to create hydrogen in place where renewables aren't established. In a major move, Tesla is looking to rid its electric vehicles of rare earth minerals, potentially eliminating the biggest environmental concern over the increasing number of EVs on the road. Even though Sweden does not host Tesla manufacturing units, the overall sentiment of mining affects the profitability of rare earth metals. There are two primary methods for mining, both of which release toxic chemicals into the environment. The first involves removing topsoil and creating a leaching pond where chemicals are added to the extracted earth to separate metals. This form of chemical erosion is common since the chemicals dissolve the rare earth, allowing it to be concentrated and then refined. However, leaching ponds full of toxic chemicals may leak into groundwater when not properly secured and can affect entire waterways. The second method involves drilling holes into the ground using PVC pipes and rubber hoses to pump chemicals into the earth, which also creates a leaching pond with similar problems. Additionally, PVC pipes are sometimes left in areas that are never cleaned up. Both methods produce mountains of toxic waste with high risk of environmental and health hazards. For every ton of rare earth produced, the mining process yields 13 kilograms of dust, 12,000 cubic meters of waste, 75 cubic meters of wastewater, and 1 ton of radioactive residue. This stems from the fact that rare earth element ores have metals that, when mixed with leaching pond chemicals, contaminate air, water, and soil. Most worrying is that rare earth ores are often laced with radioactive thorium and uranium, which result in especially detrimental health effects. Overall, for every ton of rare earth, 2,000 tons of toxic waste are produced. The EU has discarded mining as something that we don't want to be in our backyard. LKAB CEO Mostrom says he hopes the stringent permitting process for mining within the EU can be sped up in order for the company to bring finished metals more quickly to market. If we really want to pursue the green transition, we must find ways to speed up this process quite substantially, he said at a press conference. In the 80s and 90s, the US had a national rare earth mine based in California, with the elements being mined and refined within the US borders. China, though, could see the long-term value cornering this market would have on a strategic basis and began to enter the market aggressively. Where this gets particularly scary is with the defense industry. Let's use an F-35 fighter as an example. It requires 290 pounds of refined rare earths for its components, gyroscopes, sensors, and fins. And at the moment, the US is forced to get all of these from China because there is no other option. If a trade war or even a real war were to break out, the US would have no way to build additional F-35s without China sending them the materials. Without rare earths, the US would be unable to build additional missiles, planes, satellites, smart bombs, tanks, supercomputers, high-end robotics, or stealth equipment, which cripples the next gen of US warfare. This is a pretty big flaw in the current US supply chain, and to solve it would be a massive undertaking. Environmental regulations would either need to be pushed or huge costs undertaken by the rare earth miners. This is why Sweden, along with the EU, has undertaken such a project which does not fit EU's environmental policies. One potential use for the largest deposit of rare earth metals in Europe would be for the development and production of advanced technology. Rare earth metals are used in a wide range of high-tech products such as smartphones, wind turbines, electric vehicles, and military equipment. These metals are crucial for the development of green technologies such as solar panels, wind turbines, and electric vehicles, which help to reduce carbon emissions and promote sustainable energy. Another potential use would be to support the growth of domestic manufacturing industries. especially those that are based on high-tech and advanced technologies. This would create jobs and contribute to the economic growth of the country. Additionally, the deposit could be used to create a strategic stockpile. This would provide a secure and reliable supply of rare earth metals to countries that are dependent on imports, helping to reduce the risk of supply chain disruptions. It is also possible that the deposit could be used for research and development purposes. The study of these rare earth metals can help to improve the understanding of their properties and potential uses, which could lead to new and innovative applications. Overall, if there were no side effects on climate change, the deposit would be a valuable resource for a wide range of industries, promoting sustainable development and economic growth. Comment down below on what you think, and leave a like if you find value in the content we do on this channel. Hit the subscribe button for all the latest updates, and we'll see you in the next video.